Hi, and welcome to this fourth tutorial on pm4py tutorial series entitled Playing with Event Data Lambda Functions. So in this tutorial, I will go a bit deeper into ways in which you can manipulate event data in pm4py, and in particular, I will be talking about Lambda functions because they're extremely flexible and very useful for the purpose of filtering, sorting, and mapping. This will be a relatively short tutorial compared to the previous tutorials because I'll just focus on the core concept of Lambda functions and how to use them in pm4py. So before I go directly into showing you some code and running some code, I will briefly talk about Lambda functions, although I kindly refer you to more information that you can find on Lambda functions regarding Python on the World Wide Web. This is not an introduction to Lambda functions in general. However, so the idea is that Lambda functions, you could see them in a way as functions that we apply to objects of a certain object type, to perform either a transformation, a sorting, or filtering on a list of objects of that type. That sounds a bit cryptic, but it's actually not so difficult. So for example, if we have a list L, and the list contains just three names, namely John, Peter, and Frank. Then, for example, we can use a Lambda function as follows. So if we look at the bottom bullet here, so we can define the list L prime by applying a filter on the list L. And what we do is we push in a Lambda function on that list. And if you look a bit here, you see, okay, we apply a filter, and then we have Lambda name, and then we have name equals John. So basically how you should read this is we apply a filter on the list L. That's basically here. So the list L is there. We apply a filter on the list L. And what we do is every element in that list, we map that to a variable that we call name. And obviously I chose the variable called name in this example because the list L contains, names of male persons. So every element of the list is mapped to a value, to a variable called name, and then the requirement is that the name should equal John. So if we apply that Lambda function combined with this filter on the list L, what we get is an output that's kind of a list L prime that just contains the value John. In the case that in my input list L, there was no person called John, then my output would be an empty list. And if you do this in Python, then you should also cast the output of the filter again to a list. But I'll show that a bit later in one of the examples where I'm using the running example data that we've been using all along in this tutorial series. All right, so that's filtering. So for filtering, you need to basically think of a mapping to Boolean. Basically, you push that mapping into the Lambda. And then you're able to filter quite in basically one line of code. Another type of operation that you can do is kind of a transformation, which is known as a map, where you basically say, I want to map the values of the list according to some function onto something else. So again, if we use the example list L, where we have John, Peter, and Frank, then if we apply a map function with the Lambda function that maps every element of this list, which we again map to the variable called name, if we, for example, map them on their length, right? So we map each element in the list L to the length of that object. Actually, we get a output list 4, 5, 5. And why is that the case? That's because John is 1, 2, 3, 4 characters. So its length is 4. So John basically maps the length of John maps to 4. And if you look, Peter and Frank both are names that, map to a value of 5. Although it depends a bit, I think, on the implementation, whether or not this is a order-preserving map. Then the final type of functionality that we can apply using Lambda functions is sorting. So if we map, for example, again, we map our elements of the list onto their length, we can apply that as a sorting criterion for our list, right? So anything, any numeric attribute that you can think of to use a sorting criterion can be used here. So you can basically say sort, and then if we sort the elements of the list on the basis of the name, the length of the name, we actually get exactly the same sorting as we had before, because John is the shortest name, and then Peter and Frank. So that's Lambda functions in a nutshell. In this case, I use the example of lists. But obviously, what's interesting is to apply this type of functionality on event logs, because event logs contain traces, which are lists events. But in the end, an event log can just be seen as some sort of a list of traces or a collection of traces, because it's essentially you can apply this on collections of attributes. It's just a function that you apply on each attribute. So, and in Python, we've chosen actually to represent event logs as lists. So that makes, for example, sorting the event log on the basis of the number of events that are in a trace, or sorting the event log on the basis of the length of a trace, fairly easy, right? The length in terms of time, right? You just need to write a function that can map a trace onto, for example, its duration, and you can then effectively sort the event log. So we've chosen to represent event logs as lists because it allows you to, define your own sorting criterion on event logs. So how do you do that in pm4py? That's actually what I want to show in this tutorial, because there's a little twist to that in pm4py. So for example, here I have a fairly simple script that you should now see, where I have I've extended our previous import access function from the previous tutorial, and I'm doing some Lambda functions on top of the event log. So what are we doing here? First of all, I'm importing a pm4py library, and then secondly, I'm importing a specific helper sort of script from pm4py that is located in a fairly cryptic location. Namely, it's located in pm4py.objects.log.util. So all the algorithms in pm4py and the objects are kind of located based on their functionality in a Java-esque way, one could argue. And there is a specific utility script, Python script, that contains some utilities for logs, and in this case, for functional programming utilities, that script is called func. So in this script, I'm importing that func script as functools. And why am I doing that? That is because we want to retain the event log objects when we apply Lambda functions. Okay, what do I mean with that? I will explain it. So in line 6 of this script, we import an event log by applying the read access functionality on the basis of our running example of success. And in this fairly simple script, I just want to apply a Lambda function on the traces. So not on the events that are in the traces, and not on I want to basically treat the trace objects as the primary input for my Lambda functions, and not the events in traces, but just traces. All right, so First of all, what I would like to show in the output of this script is I will print the event log so that we can look together, okay, how does the event log look? You know, it's a list. And then we're going to print each trace in the event log in more detail. And then what we're going to do is, as I said, event logs in pm4py mimic list objects. So you can apply any form of function that you can apply for lists on an event log object. So in line 10, what I'm doing is I'm applying a filter, and I'm applying a filter that's on the event log, as you can see. And I'm selecting all those traces that are of a length bigger than 5, right? And I'm casting that filtered object to a list. That's what I'm doing in line 10. And then in line 11, I'm printing the resulting object of this lambda filter applied on my event log. And then I'm also printing the type. So what's the problem of this, if I run this code, is that, as we will see later, is that I'm using an event log as an input. I'm filtering all the traces in my event log that are having a length bigger than 5. However, this filter function that we apply returns some lazy evaluation filter object that we need to cast to something. And we can, for example, cast it to a list. But when we do that, we lose the additional information that an event log actually contains, like the classifier information that I've been explaining in the previous tutorial. And that's why what we did in pm4py is we kind of wrap around the standard Python Lambda functions like map, like sort, and filter. And those wrappers are basically in the func utility. And they make sure that the resulting output of the underlying Lambda function that you apply, so that the filter, the sort, or the map, is casted back to an event log and retains all the attributes. So what you see in basically from line 14 to line 16 is applying the exact same Lambda function in pm4py, like the one that you see in line 10. So we filter all traces in the log that have a length of 5. So we use functools.filter underscore, and we've chosen to rename that specific filtering function with an underscore to not use the same name as the filter function, which is defined for the Python language itself. But this is a wrapper around the filter function that you also see applied in line 10, but it then makes sure that the result is casted to a list, but then encapsulated again in an event log object, so that you don't lose any information that might be useful for other algorithms to use. So in the end, we also print the type of the trace log that we obtain from applying this filter function from pm4py. And we, in this case, let's not print the length, but let's just print the trace log itself. And because it's going to be an event log, I'm going to also print each trace individually. So kind of a long introduction for this specific script, but now I'm going to run it, and we're going to go through the print statements that it will return together. And for that, I have to scroll up a bit, scroll up. And let's take a look. Yeah. So what you see in the top of my output window here below is the result of the print statement in line 7. So you see the print statement in line 7, which prints the event log. And basically you observe that the event log is a list, as you can see here, and it contains attributes of type, and the first, sorry, it's a list, and the first element of that list is having an attribute that is called concept name and value of 1, and then you see that it contains some events. And that event, that is again, those events are actually the trace, so the sequence of events. It's again a list. It's a sequence of events belonging to the case in this event log that is identified by a value 1. That's what we see here. So this is a result of the print statement in line 7. So it's actually printing the whole list. So now I'm going to scroll to the right. So you see all kinds of information of these events. And then this basically shows that Python is, shortcutting our printing of the trace, the events in that specific trace. To continue to the right, and here again, so still I'm looking at this top row here, and we see all kinds of information in this case of cases. But what I would like to show you in the end is that's kind of the data that is printed by the print function of an event log in pm4py. So it has its own custom print function, and it shows you basically the attributes. It shows you basically a list of traces. All right. So since it's a list, or it behaves like a list in Python, you can iterate over the traces in the log. So if you look at line 8 and 9, I'm iterating over the traces in the log. And since in this running example, there's a total of 6 traces, we have a total of 6 individual lines, which you also see in the first line in a way printed, but compressed in that sense. So this is the output of that specific statement. Now, the thing is, and this is important, so here we print, here in line 10, we apply this filter that I've been talking about that filters all the traces of length bigger than 5 and puts them in a list. And if you look closely, and because in this line that I'm now selecting in my output window, you see the result of the print statement of line 11. So that's printing the filtered list, the trace list, the filtered list based on the Lambda function that we see in line 10. And if you look carefully, you see that this only contains the trace with concept name 3. And if you take a look at the events, you see that there's a register request at some time. I'm not sure if we see all the events for that specific trace. No, it's not there. And maybe there could be that there's another trace. But the point is that if you take a look at line 12, we lose the information that this actually comes from an event log object. So for Python now, the variable trace list is no longer an event log, but it is actually it's now a list. And in pm4py, we're actually storing meta information in the event log object. Maybe I can actually show that. Let me search for it. I always need to search for it myself, how we call them exactly. But for example, an event log has an attribute called attributes, extensions, omni, and classifiers, which represent attributes that you can assign to the event log, and extensions and omnipresent attributes. So if an object is an event log in pm4py, you can actually query those values, which I'll show you a bit later. But if it's not an event log object, you can't. So if we continue in this script, you see that at line 14, we applied a pm4py specific Lambda function, which also filters the log for traces that have a length bigger than 5. And then we print the type of that trace log. And you see that here, I'm highlighting it right here in the bottom. So it's class pm4py objects log of event log. And although when we print it again, so that's this line, it looks very similar to the print of our trace list, which was over here, it actually contains more information. And as you can see here, actually, finally, I printed 2 traces that are longer than 5, have more than 5 events, which are trace with attribute value, with name value 3, and a trace with the concept name value 5. So to illustrate a bit what is the problem is if I extend this script by saying, for example, I would like to print a trace log, and I would like to have the attributes of the log that should be defined. So I didn't prepare this specific demo, so let's keep our fingers crossed that this goes without any problems. And I think I know what I did wrong here. Yes. So if I, in the end of this script, print the attributes of the trace log, and for the sake of readability, I will remove a few print statements from before, so that it becomes a bit more clear. Perks of doing a sort of semi-live demo. Anyway, so here you see that I'm printing the trace log.attributes. So the trace log, the attribute called trace log attributes, but I can also print trace underscore log.classifiers or print trace underscore log. So these are all attributes. These are all attributes that are always present in an event log object. So if I now run the script again, so I've now omitted all the printing. I'm just creating this trace list with my Lambda filter in line 10, and I'm creating my trace log in line 14. If I run this script, it's guaranteed to run, and it will, for example, it will print the attributes first, which is origin CSV. So apparently this success file was once converted from a CSV file. And finally, there's no classifiers defined in this event log, and there's no omnipresent, no globals. So omnipresents are actually the globals of success. Again, watch the previous video if you want to know more about that. But if I now do the same for my trace list, I have a problem. So if I print trace list of attributes, you already see actually my PyCharm editor warning me that attributes is not defined for the class list. And if I now run this script, you'll see that I get an error, like list has no attributes. So that's why we have these func tools in place in pm4py, so that you can apply all kinds of filtering, all kinds of sorting, all kinds of mapping, if you would like, to compute all kinds of statistics and all kind of views on your data, and exploiting Lambda functions, right? So, for example, if you would like to compute the average duration of the traces in the log, you should just basically map each trace in the log. So you write one Lambda function that, takes a trace, takes the timestamp of the first event and the timestamp of the last event, and it subtracts the timestamp of the first event from the last event. And then you have the duration. So you can make a map using that function. And then basically you divide it over the number of traces, and you'll have your average case duration. So we've also chosen that to not provide so many functionalities for that in pm4py, because we think it's fairly easy to implement it using, for example, these func tools that we have. All right, so another thing that might be, of course, interesting is it might be, of course, be the case that you actually would like to filter on events rather than traces. So you would like to use this filtering machinery, but you don't want to use this on traces, but you want to use them on the individual events. And because traces themselves also mimic pm4py, Python lists, you can basically do exactly the same for events. The only thing you need to do is you need to convert the event log into what we call an event stream. So an event stream in pm4py is basically a sort of flattened representation of event logs. So where an event log is a collection of traces that contain events, an event stream is just a list of events. And within the events, we keep track of, what is the case identifier to which this event belongs. And obviously, it's fairly easy to do this. So an event stream, in a way, could be seen as, a list representation of it's like a CSV file. So how do you do that in pm4py? So let me now go through this second script that I have here, again, using the same event data that I've also shown you in the previous tutorials. If I read the event log using the reaccess, then I can convert it to an event stream by just applying this pm4py.convert to event stream function here. So again, I'm just importing the pm4py framework and the func tools like in the previous script. Now, for example, what I would like to do is I would like to filter all the events that are basically executed by a resource called Mike. So what I can do on my event stream, and remember that the event stream is just a list of events, and by default, it, for example, just takes the order as it sees the events in the event log. Obviously, if you would like to order them by timestamp, you can again do so by taking the event stream and then apply a sort with a Lambda function on timestamp. That's all you need to do. But if I would like to filter all the events that refer to a resource called Mike, I again use the filter underscore function from the func tools that I've imported from pm4py util, so pm4py objects.log.util, and then we import the func module, and I retain all the events that are having a value Mike for resource. And if I would be interested in resource groups, I can easily rewrite the Lambda function to be e.org resource in, and then a collection of names, right? It's basic Python stuff. So in this script in line 9, I'm printing how the event stream looks, and then I'm going to print the resulting event stream, so all the events that contain Mike. Then I'm printing every individual event. I will convert it back to an event log, and I will then print each trace in that event log. So in line 12, I'm applying convert to event log, a function from pm4py, using the event stream as an input. So if I run this specific script, I'm going to see, first of all, the type of the event stream, which should just be, a pm4py event stream object, as we can see here. And then I'm printing all the events in the event stream. So again, event stream mimics a list, so you can just iterate over it and apply functions on top of it. And as we see this first event that I'm printing, I'm going to scroll a bit to the right. What I want to see is that I can only see the resource values Mike. And as you can see here, all the time we see resource value Mike. So the filter has, worked successfully in this example. And then if we scroll a bit down, so we see that there was quite still some events that were executed by Mike. Then if you scroll a bit down, we see the individual traces that I've printed. So in fact, so here in the bottom, where basically from this line onwards, what I've now highlighted in blue, you see all the traces in the event log. So I've converted the event stream back to an event log, because in pm4py there's like a predefined attribute that we use when you have converted an event log to an event stream that allows us to then do the conversion backwards. And we actually see that in this example data, the Mike was active in every trace, because this actually only contains, each trace only contains the events where Mike plays a role. So we see that in trace 1, he has somehow executed the check ticket activity, right? You see that in this first line. Let me try to select it. Right, so in the blue highlighted line, you see for trace 1, there was a check ticket activity, and it was executed by our friend Mike, and that was all he did. But apparently for the second trace in this data set filtered by Mike, there's actually more. So I've now highlighted in blue again, there's actually more activities that he performed. So he performed the register request, and that's what he did, and apparently also the check ticket, right? So he did more in that case. So I hope you can see that actually using this is quite powerful, because assume that you have a real data set with resource information, and you want to, create specific subsets of event behavior for specific sets of resources. Then you can actually quite easily compute all kinds of statistics. So if you know there's this machine and I'm interested to compute for that machine the average duration of the activities that it performs, and I also want to compare that to this other machine, you basically need 2 filters, and then you can aggregate by, again, using a map function. So again, super powerful stuff to crunch your data in a variety of ways. Basically, that concludes the tutorial of today. So I think a lot of filtering that we would like to do in process mining data is, on the one hand, is very much depending on the data at hand and the process. But with these functionality, I think it's fairly easy to set up powerful scripts that can do all kinds of filtering and could create all kinds of derived statistics on the basis of the filtering. So that was what I wanted to show to you today about Lambda Functions in pm4py. And in the next tutorial, I will be going into a bit more playing with event logs. I will be going into a specific set of functions that you can apply on top of event logs to, for example, filter the event logs, or to sort them that are a bit more advanced and that exploit common process mining functionality. So thank you for watching, and I hope to see you in the next tutorial.